breaking the wall of hidden electronic waste. Johanna Zikulnig. Falling Walls Lab, Austria.
Hi. So we all know that electronic waste is a huge issue. We imagine discarded smartphones or old laptops. However, there is a more subtle but equally alarming dimension to this problem, the hidden electronic waste. Every day, hundreds of thousands of small electronic devices are integrated in everyday devices like smart packaging, textiles, or for logistics. However, due to the high level of integration, they are discarded with the product, so they won't end up in electronic waste. Instead, they will most likely end up in municipal waste. In the European Union, 50% of the municipal waste is recycled. However, this mainly applies to sorted waste like plastics or metallics. The small integrated electronics is most likely to be invisible to the recycling system, which means it will land in incineration or in landfilling with all of the valuable materials which are integrated like batteries, cars' raw materials, silicon chips just being lost. And with the emerging Internet of Everything and ubiquitous sensing, the issue is going to escalate. In my work, I've developed a wireless, modular, and sustainable sensing platform, which is designed to minimize the environmental impact in disposable sensing applications. It's built around a wireless sensing chip with a printed antenna, sustainable substrate materials, and so on. And what truly sets this work apart, actually, is that sustainability is not just a claim, but it's considered from the very beginning. I applied life cycle assessment, which is a tool, a scientific tool, to quantify and assess the environmental impact of a product or system. And with this, I took this to make informed design choices. Like here, for example, you see that although the weight percent of the substrate is the largest of this whole sensor tag, it only contributes the least to the actual environmental impact. Also, by using digital technologies for manufacturing, we can adapt the design on demand without the need for wasteful tooling or batch sizes of millions. To summarize this, it's battery-free, it's a bio-based and recyclable substrate. It uses printed electrodes and antennas to form a sustainable solution for single-use applications. This work was published in Nature Scientific Reports, and I believe it really shows that functional sensing does not have to come at the cost of sustainability. And with doing so, I aim to break the wall of hidden electronic waste. Thank you.